Oh, it's winter, isn't it? Let's go straight to version 3. And we can fall asleep, that's okay. So 01 unlimited knapsack problem. So I used defines so I wouldn't have to wire magic things. Somebody wrote me, I don't remember who it was, said they code was blowing up at 1024. I don't think it was someone here. Yes, I think so. Yeah, so if you allow a capacity of 1024, right, you probably want your cache array to be able to store index 1024. So you want to define it as an array of 1025 integers or whatever. That's just an edge case. So I made a structure for passing around to max val. So my structure is called answer, and it contains an integer maximum value and then an array of item list, which is, you know, how many of each item I want to get that maximum value. So we talked about this a little Wednesday or Thursday. And then this is my cache. So it's an array of struct answers up to whatever the maximum capacity is. And I did a little trick. Sometimes I want to return 0, like if I can't fit anything in my bag. So I just set element 0, which I would never use, to have a max val of 0 and an inventory of 0. So anytime I want to return 0 from max val, I could just return save bracket 0. So this is the structure for items in our inventory. So there's a weight, a value, and a name. So I think a lot of people did that. And then tons of function prototypes. Nothing too shocking here. So max value takes in the inventory, the number of things in the inventory, and the bag's capacity, bless you, and it returns an answer. Read inventory, usage, cap are just, and init are just startup routines. Echo is used to show what's currently in our inventory, and print answer shows, I don't know what that does, we'll find out. Oh, it just prints out a particular answer in a pretty form. So it says here's the maximum value, here's a list of items that you have. Echo I use to echo a copy of the original knapsack.data file. All right, so just bundling stuff in. So main program, so inventory, in bracket num items, right, that's the inventory I'm going to store knapsack.data in. This is the number of things in that array. Bag's capacity, temporary variable, temporary answer. Check the usage on the arguments. So usage, I just pass it your argc, argv, and if it finds a valid integer there, it'll return that integer, and that's what I set equal to cap. If it doesn't find valid arguments, it returns a 0, and so if it comes back with a 0, I just return from my main program because there was an error, and usage will print error messages. This initializes the save array, the cache, so it sets things to 0, so we know if something's been popped in there or not. This processes the knapsack.data file, so read inventory populates the inventory array, and it returns the number of things it read. And if it encounters any errors, it will return a length of 0, and that tells my main program that there was a problem with knapsack.data, and I kick out of here at that point. Otherwise, we continue, we echo the contents of knapsack.data, so that just pre-prints the output. And then this calls maxval to find the maximum value for that inventory and a given capacity. There's the answer prints it out, and that's the end of main. So this is all deferral, right? There's nothing really smart happening in my main program. It's just handing off to a bunch of functions. right? This is totally typical modularization. So the main program is a structure of what I want the program to do, but it's missing all of the details, right? We don't know how to print the answer. We don't know how to find the max value, how to read the inventory, but those are the steps I want. And this is basically taking the highest level pseudocode and just writing a function for each piece of it. And then we go in and we start writing the functions. So max val is the most critical function probably. So first case, if the capacity is less than or equal to 0, we can't store anything in our bag. I just return a 0, which I put in element 0 of save. You should never come to this case though. I didn't check to see if that's what happens or not. Otherwise, I check our cache and see if the value that's saved in there is, so I think I initialized to -1. So if it's bigger than -1, I've stored a value in there, I go ahead and return that. So that's reading from the cache and circumventing all of the recursion. Otherwise, big long recursive mess. So max is -1 to begin with. So that means we haven't found a reasonable value yet. So I loop on the number of items in knapsack.data, right? Not the maximum possible number of items, not the capacity, but the number of items in knapsack.data. So for each of those, if that item is small enough to fit in the bag, we do all of this. So I explicitly make a variable called diminished capacity, which is the initial capacity minus the weight of item I. And then I call max val on that diminished capacity, and what it returns, that's temp answer. Okay. And then, since what I'm doing at this part of the loop is I'm saying, let's find the max val if we start with item I. So whatever inventory of items we get back from max val, we want to add one more of item I. So I increment the item list element I in our temporary answer. And I update the max val part of our answer by whatever value we get from putting item I in our bag. Right? So what's going on here? Temp answer is the answer to filling a bag of this diminished capacity. It's the best possible value and the best inventory that gives us that value. But what we're doing here is we're saying, okay, let's take that best value, that solution for a diminished capacity, and let's also add to that one of item I. Right? So we increase the count of item I by 1, and we increase our maximum value by the value of item I. Right, that's the heart of keeping track of the list of items that give you your value. But we're doing this all on a temporary, right, temp answer. And then we go ahead and we do this thing we did in class. Let's see if our temp answer's max val is better than the current max we have. If it is, then we're going to change max to be the new max value. And I have this structure called max answer, which I set equal to temp answer, and that's going to record the inventory. And we do that across the collection of all possible items. So I've mentioned to a few people in class this week, right, when you're writing code like this, for me, sometimes I have to just sit down on a piece of paper and write out what my variables are. Right? Even if you think you're naming them well, I'm not good at naming them, I guess, because I always have to write down, okay, so what is temp answer, what is max answer, right? So in this case, temp answer is just a temporary structure that stores the max val and the corresponding inventory. Max is the actual number of the maximum value, and max answer is my structure that corresponds to that max value. All right, so when I come out of that loop, I check max, and if it's still equal to -1, I never did this, which probably happened because I never found an item that fit in my bag. So if max is still -1, I didn't put anything in my bag, so I'm just going to return 0 and say the max value is 0. And again, that's just coming from element 0 of my cache. Otherwise, max is the max value. So I'm going to save that entire answer structure into my cache, and I'm going to return that as the value of max val. So that's the essence of max val. It's really small. See, it's only that big. Right, so most of the stuff is happening right in here. And that's all saying what happens if we put item I in our bag. Where does that lead us? But getting this or a similar structure that works, right, that can take lots of trial and error. Okay, when I wrote this was not the first way I did it. I tried it a few other ways, and it kept getting more and more jumbled up. And it took a few tries to decide, okay, so I'm going to have a structure that stores a value in an inventory, I'm going to return that from max val, and so on and so forth. It's a process, right? It's like trying to build a house on a side of a cliff. It's going to take a few tries if you haven't done it before. All right, and then these are all just details. So this is reading the knapsack.data file. So I open the file for read access. If it returns an error, I just kick out right there with a 0. So a return of 0 tells me something went wrong. Read a line, try to scan it as 2 integers and a string. If it doesn't scan successfully, print out an error message, return 0. That's the failure. Otherwise, I'm storing those integers in inventory.weight, .value, and .name. And the integer is right, I pass the address of that. And then I increment the number of items in there. And if I have too many items in knapsack.data, I'll print out an error message here. I'm not going to check that on your code. And then this loops over all of the input in your file. And when you're done, close the file, and inventory len should be the total number of things you read in.
Would you care if we change the way we have our structure for items?
You can do whatever you want with your structures, absolutely.
Okay, sweet.
Yeah. Usage is checking the arguments, so I make sure that argc is 2, otherwise I print out a reminder of how you should invoke the program. Although if you went on and gave me the option of typing in a capacity instead of giving me an error, that's cool. If you got an argv1, I go ahead and try to scan it as an integer stored in capacity. If that fails, then I give you a usage message and return an error. If the capacity is negative or bigger than the max cap, I give you an error message and I return failure. Otherwise, I return the capacity. So that just takes care of all the parsing, but it does it in this separate function, so my main program stays easier to look at. Initialize goes through and sets up my cache. So I set the max val for every element to -1. I set the item counts to 0, and then I set max val on element 0 to 0 so I can return that when I want to return a 0. And this prints the contents of knapsack.data, so I just print them out in a loop. And then this prints out the final answer, so I pass it the answer plus the inventory of items. If max val 0, I say no solution. Otherwise, I print out the max value, and then I show how many of each item you should have. And that's that. So that's a very modular implementation using lots of structures. Okay. Now you don't need to do all that. So so this one I used parallel arrays. So I have an array of max values. I have an array of how much of each item I want. and I have an array of weights, an array of values, and an array of names. Right, so no structures anywhere in sight other than arrays, but it's basically the same code. Right, so my maxval function itself takes an array of weights, an array of values. I don't care about the names when I'm finding maxval, how many weights and values I have and the capacity, and I'm returning an int. And in here I was using this cache, this save array, to actually store the inventory instead of returning it. And that seems to be something a lot of people are doing, and that works in some cases. It can be a little sketchy sometimes, right? One way to approach this business of caching so here's a function, and here's some heavy recursion going on, and here's where you compute your answer, and here's where you return. Right, so that's your function without caching. If you want to save your results, in the very beginning here you can say if, let's say you're calling this on n, so check if cache n is valid, whatever that means, positive or a flag set or something. And if it is, return the value from that cache. Otherwise, down here, before you return, save your answer in the cache. And the only time that we're doing anything with this memory cache is right in the very beginning and right at the very end before we return. So it kind of wraps around existing code that has all of this presumably heavy, computationally intensive recursion in the middle. But since we need to store an inventory of items, and that's being stored in the cache anyway, in some cases, like that version I was just showing you, you start using that cache inside your recursive code itself. And there's nothing wrong with that as long as you're careful about doing it and you understand that if you decide to change the caching mechanism, you change this and this, you might also have to change some stuff inside here. Right? Or you can split it out and use a separate way to store those temporaries. So yeah, this is pretty much the same code. I think it's a fair bit longer. So if the capacity is invalid, return 0. If the cache value is valid, return that. Otherwise, so I was counting how many times we called just for fun. So if the weight is small enough, then call your value function, which should populate the cache, right, with the inventory count. Add item i's value if that's bigger than the max, save it, and here I just decided to save the index of the item that gave me the max value. So when I come through and I finish, if my max value is -1, I'll return a 0. Otherwise, I found a solution. Max will be the maximum value, and max index will be the item number that I started with that gave me that maximum value. Which means if I go into my cache and what the heck did I do here? Yeah, this got kind of weird. So this was the array of items that gave me the maximum value when I called maxval up here. right? So that was called on this diminished capacity cap minus weights I. So I just take the item counts from the cached value for caps minus weight of I, and I copy that into the cache indexed by the capacity, and then I bump up item max end. So that to me was really confusing when I went back and looked at it. So I did that other version instead. But that's a way to do it without structures. It's just parallel arrays. You just have to, again, write everything down, make sure you know what corresponds to what. And then the rest of this is the same thing. It's just broken out in separate variables. And V2 is in between. So questions, comments?
How much are you taking off for inventory?
Probably 10. So programming assignments don't count a whole lot of points in this course, right? Which I keep debating every time I teach a course, how much to weight programming assignments. If I weight them too heavily, then there's just this urgency. I got to do really, really well on this, right? And you're going to kill yourself trying to get every last point, and you're going to miss the sort of bigger pictures, right? The inventory is nice icing, but I really want people to, you know, understand dynamic programming, writing something that uses the function itself and stuff like that. And if you got that, you know, I'm fine with that. I think you got, you know, 90% of what I'm after. That's the bulk of it. If I don't weight programming assignments very much at all, then people don't do them. And that's really bad, right? So I'm always trying to find that sweet spot.
What's the most creative function for max value you've seen?
Mostly they kind of look like what we've been talking about.
Okay.
Well, you got a creative way?
The way I did mine is to find the best item to put in a bag.
Mm-hmm.
I divided the value by the weight
Okay.
to find the best weight value to weight ratio.
Okay.
And then when it finds an item, if the weight of that is less than the knapsack, it stores it as the best item.
Okay.
And
Does
then
that always give you the max value?
Yeah.
Okay, it sounds like a greedy algorithm.
Yeah. It was a little complicated because I had to make the so if I had like item I,
Mm-hmm.
when I divided by the weight, I had to make the item I of weight a float, so I
Mhm.
can get a decimal back, so it can not just return integers. So if I had like 15 divided by 5, it'd be the same as 25 divided by 7 because it rounded that down.
Okay, so you actually wanted the highest value, including the decimal part?
Yeah.
Okay, so you take the capacity, you divide by the weight, and then you're multiplying by the value?
No, so what I'm doing is I have a for loop
Mhm.
that goes through each item,
Mhm.
and then my temporary value is equal to the item value divided by the item weight.
Okay,
So then it gives it back a ratio of like, so if I have something that
so like
costs
dollars per pound.
Yeah, dollars per pound. And then if temp is better than what the best is currently, it stores the best as temp.
Okay.
Well, yeah, stores temp into best.
Okay.
And then it goes to the next item, and if that item beats that item, then it'll restore. If not, it'll just keep going.
Okay.
And if it doesn't find any, it'll keep it. But before I store it, I check if it's less than the size that's in the bag, so it doesn't
Okay.
like store too much. And then once it goes through the whole list, I go out, and then if the item is less than the size, I created a fourth structure in my item
Mhm.
as amount.
Okay.
And every time in this function it counts the item, it increments the amount, so I can
Okay,
print it back
so you get
later.
your inventory automatically?
Yeah.
That's cool.
And then I make the best value equal to the item best value of item value plus the max val, and then
Okay.
it recalls it again and does it again.
Okay, that's got some slick aspects to it. which is cool. I think it's still greedy, and I think that will not always work, although a lot of times it does.
The only time I seem to get an error is if I have a value in my knapsack.data that equal, well, a weight or value that equals 0.
Okay, yeah, we won't do that.
Mostly because dividing by 0 causes a problem.
Yeah. Well, if it's got any value and no weight, then you want to like load up on that one,
Yeah.
right? And we were talking yesterday about what to do with negatives, and negatives are interesting.
I have my function set, so if like I get a value that's anything less than 0, it just,
Yeah, that's fine. And I'm not going to test it with weights or values less than or equal to 0. So, because those are all kind of edge cases at best, or break the algorithm at worst.
I wrote a PA5 testing script
Okay.
that randomly generates files. And
Oh, cool.
And you should probably try and run yours on that and see if it works.
on what?
I can like put my PA5 test file on temp or something like that.
Mm-hmm.
That would be
If you
cool.
wanted to test it.
I should test mine, see if it works.
It takes like 10 minutes to run through all of it.
How do you know if it's right?
The exit status. Well, so it doesn't check for tricks. Actually, sorry. I was using it to test for seg faults and stuff.
Okay, cool.
I can modify that.
That's good.
I was checking the exit status. I think, did you use tests that didn't have a weight of 1?
Yeah. Like greater than 1 or less than 1?
Like, did you have, so basically you want to have cases where it doesn't, the weights of your items don't evenly divide into the capacity? Because I think that's where you run into edge cases with that algorithm.
Yeah, so here's one example. So weight of 2, value of 4, weight of 3, value of 7. So value divided by weight. This is 2, this is 2.1 something, right? Or 2.3. So this is your most valuable item. But you don't want to put it in your bag if your capacity is only 4. If you have capacity 4 and you put this item in, then you get $7 out and you can't put anything else in your bag because you only have 1 pound left. If you put 2 of these in, you get $8 in your bag.
Okay, I see.
So one big difference is whether you have an item whose weight is 1.
Yeah.
Right? If you have at least one item of weight 1, then you can always fill up your bag completely. And I think your approach tends to work well if you can use the whole capacity,
Mm-hmm.
right? But in this case, we do better by leaving 1 pound unused in the bag, and I think that's what makes the greedy algorithm not always optimal.
Yeah.
But these are interesting to analyze, right? You can do a whole mathematical analysis of something like this solution to knapsack and try to prove that it works or when it works or that it doesn't work.
Yeah, so I just tested it out. It does run into that problem.
Okay. Anything else? You don't have to stick around. You're welcome to. I'll be here until 10 of.
Club today?
There should be club today. There usually is last week. But I think I have a student coming at 12, so I'm going to miss club again. I should change my hours to start at 12:15. Anybody here ever played with Game Conqueror? I was messing around with about this the other day.